technology. And we're now going to move on to a session called YOLO Supercharged, harnessing AI native power. And it's my pleasure to introduce a very distinguished speaker, Bram Verhoef, who's joining us from the field of statistics, psychology, and neuroscience. With a PhD from KU Leuven and extensive postdoctoral research at prestigious institutions like Harvard University and the University of Chicago, Bram's expertise lies in computational neuroscience. Wow, particularly in understanding the intricate mechanisms governing attention. I could definitely use some of this. So in 2017, Bram returned to Belgium to join IMEC as principal member of technical staff, spearheading the development of algorithms for a groundbreaking analog compute in memory deep learning chip. In 2021, he co-founded Axelera AI and currently serves as the head of machine learning, leading the charge in algorithm optimization for Axelera AI's cutting-edge deep learning accelerator. Very exciting stuff. So today, Bram is going to walk us through the remarkable achievements of Axelera's AI Metis platform, So this platform offers industry-leading performance and unparalleled usability, all at a fraction of the cost and power consumption of existing solutions. Tick, tick, tick. Prepare to be astounded as Bram unveils the incredible results of their hardware and software synergy, optimizing YOLO models for inference on edge devices. Without further ado, let's welcome the great Bram Verhoef to the stage. Thank you. Give it up for Bram. Thank you very much.
Thank you very much. Great introduction. It's a pleasure to be here. I'm Bram. I'm the co-founder of Axelera AI. I'm also leading the machine learning efforts. Let me check. I'm looking for my presentation. All right, I have to share. Be right there. All right. There we go. All right. So what we are doing, so probably most of you don't know Axelera AI yet. So let me briefly introduce the company, where we come from and where we're going. So we are building this powerful, efficient, cost-effective, and user-friendly hardware and software AI platform. And we do this for computer vision applications and generative AI at the edge. So the typical kind of markets that we target is the retail, security, robotics and drones, industry 4.0, healthcare, and automotive applications. So we started our company 2 years ago and have been working really hard to build up a company that now consists of over 130 employees. And we have offices throughout Europe, in Eindhoven, where we have our headquarters, but also in Zurich, in Leuven, where I'm from, in Bristol, Florence, and we recently also started operations in the US. We have people coming from great companies like Google, Intel, and so on. One nice feature is that we recently started to really ship our first product to customers. So this is our early access program. A selected number of customers is now trying out our product, giving us feedback. And the goal is then to move towards general availability, mass production, beginning of 2024. Now, question, of course, is what differentiates us from the other solutions that are on the market. And here I give you some insights into what that is. So we have, on the one side, our hardware, proprietary hardware that we have developed. This is our digital in-memory computation array. And the nice thing about this array is that it merges the compute elements and the memory elements together. So they're interleaved. And that has several benefits. So if you compare to traditional hardware, that is von Neumann hardware, you have your memory and your compute elements. And every time you need to compute something, you need to first fetch from the memory into your compute elements, do the computation, and send it back. Now, what we do is we do the computation all inside the memory itself. And that has several benefits. For example, because we don't have to fetch the data from memory anymore as often. Well, we have a much more power energy efficient solution. Also, because memory and compute elements are just stacked, interleaved together, we have a much smaller die area, which allows us to be much more cost effective. And because our array that we use for the matrix vector multiplication, matrix multiplication that are so common in deep learning algorithms, we have very high throughput. We combine now this array with RISC-V architecture. And with the RISC-V, we control the units. We have very flexible support for different kind of activation functions, and it makes it all very highly programmable. On top of the hardware, we have our software SDK, the Voyager SDK, which makes it very easy to build up your applications, even with almost no code, and deploy then your model or your full pipeline for inference at the edge. So combining all these features, hardware, software, and so on together, we come up with a chip that can deliver 214 TOPS. And compared to other solutions, similar edge solutions that are out there on the market, that's a very high number. And the nice thing is it's not just very high performance, it's also very cost effective. So if you compare, if you look at the number of operations that you get per dollar that you spend on a solution, well, then we do up to 8 to 10 times better than existing solutions. And also, the energy efficiency that you obtain from this Axelera Metis AI PU is very high. So we run at typically 15 TOPS per watt, which is very good when you look at all the solutions that are out there. So this is what we have developed and what we are still working on to further improve. And like I mentioned, we are now in this early access program, but we have also been looking already at different YOLO models and looking at the type of performance that we can get out of our solution. And I would like to share some of that with you today. We are still expanding our set of models that we run. But now, particularly for YOLO, we have been looking at YOLO V5S and for YOLO V8S. In these models, we have been replacing the activation functions with a ReLU, making it a little bit easier to deploy, but no worries. We can also handle the typical SILU activation functions and others. Now, if you look at the typical resolution of 640 times 640, you can get frames per second of like over 800 for the YOLO V5S and over 400 for YOLO V8. So these are high throughput numbers that you can get, and more about this to come. In the upcoming months, weeks and months, we will publish more numbers here. Now, one particular kind of aspect of our design is that our array in which we do the matrix vector multiplications works with int8 numbers. So int8 weights are being stored, and also int8 activations are coming in to do these matrix vector multiplications. So this requires us to first quantize the model before we can deploy the model to our hardware. And quantization can be tricky. Often it can either take a lot of time, like for example in quantization or training, where you have to set a lot of hyperparameters and play around with different kind of things. And one often loses quite a bit of accuracy. So to mitigate those issues, we have developed a very effective and accurate post-training quantization flow that just takes in a pre-trained model. You have a couple of 100 images that you just flush through the model. We collect some statistics at different kind of stages, use those statistics to estimate quantization parameters, and finally you end up with a quantized model that you can deploy on the hardware. And this all happens in a very automated way. You don't have to know anything about quantization, actually. Now, if we use this post-training quantization flow for our hardware, these are some of the numbers for YOLO that we can achieve. So here I show for different kind of models going from YOLO V5 variants to YOLO V7, YOLO X, YOLO 8, and YOLO NAS. We have evaluated them on the full COCO data set. In the middle column, I show you the MAP that you can expect for a full precision, so floating point model. On the right column, you see what the int8 quantized model MAP is. And then in the final column, you see the difference between the floating point model and the quantized model. And as should be clear from this is that the quantization loss is very minimal. It's usually 0.5% or less. So if you deploy a model on our hardware, you can really expect the floating point accuracy or almost a floating point accuracy that you're used to. And one of the interesting aspects of the quantization flow that we recently actually noticed is that we looked at this great YOLO NAS model and quantized it with our post-training quantization flow. And actually, when you look at the quantization drops that we get in accuracy and compare them to quantization or training that is typically used for YOLO NAS, then the post-training quantization flow that we employ actually does slightly better. So this is usually, it's the opposite quantization where training requires a lot of training during quantization, giving you better performance and accuracy. Well, here we see a slight opposite. So that is for us a testament that the quantization that we're working on works really well. And here I show a lot of YOLO numbers, but of course this also works for other models like a typical ResNets, OpenPose, and so on. So if we've evaluated it there as well, and we lose very little accuracy. Now, so what I've shown you here is that we have come up with a solution that gives you very fast and accurate YOLO inference. And depending on the needs that you have, you can start from an N.2 model at 149 euro to start in. So coming back to one of the earlier questions that were posed by the audience, is it possible to run YOLO models at around $100? Yes, it is possible. Here we have a solution for you. But you can also go up to like edge appliances at the server side, where we have worked together with our partners like Seco, Advantech, and Dell to really give you even peta-op performance if that's what your application requires. So powerful solutions. And this is my my presentation. I'm happy to answer some questions. And also I would like to mention that Nicola, our business development executive, is there with you in the audience in Madrid. So if you have any further questions after the Q&A, please contact him and ask him about our solutions, how you can get involved, and any questions that you have. Thank you very much.
Fantastic. Thank you so much, Bram. Okay, and Nicholas, sorry to put you on the spot, but where are you, mate? Nicholas, there we are. Okay, you see the hand is going up there. Nicholas is in the house. If you have questions about this, if your Christmas card list or your Christmas present list just got a bit longer as mine did, just make sure to grab Nicholas, have a coffee, and find out about this incredible hardware acceleration and this brilliant quantization and floating points. And oh my goodness, all the good stuff. Tick, tick, tick. That was absolutely great. So my dear friends, I'm afraid we don't have any time for questions because that was such a brilliant in-depth presentation. So Bram, we're going to direct people to ask their questions, or difficult technical questions, to Nicholas here, and he's going to loop you in via LinkedIn or Slack or whatever to kind of answer some of the questions directly with some of our delegates here. But thank you so much for taking us through there. That was absolutely mind-blowing stuff. I loved it. I learned a lot as always. And one more time, my dear friends, and joining us virtually, please give a big round of applause for Bram Verhoef and Axelera AI. Thank you.